Hello all, this is Sandeep Kumar and I welcome you back to my YouTube channel Math with Sandeep. We are in the chapter of limits and in the last video of this particular chapter. So it's about limits of the form 0 power 0 and infinity power 0. Okay now, so when limits are taking the form of 0 power 0 and infinity power 0, we'll see how to solve and how to find those limits. And of course we will be using L'Hospital's rule to solve these kind of problems. Now let us see how to solve the problems based on it. We'll start with first question, but before that, if you are new to the channel, please don't forget to subscribe the channel. Okay, here is our first question. Limit x approaches 0, x power x. Particularly it is x approaching 0 plus a number just more than 0. Okay now, if you directly substitute this particular value, it is in the form of 0 power 0. So it is taking 0 power 0. Dear students, all these models are done using same method. All the problems which are taking 0 power 0 form or infinity power 0 form are all done in same way. So what we will do is, first let us assume that y is equal to this particular limiting value. Limit x approaches 0 plus x power x. So let us assume that its value is y. Next we will apply logarithms on both sides. Logarithm with base e. So if I apply logarithm with base e on both sides and log will go inside. So limit x approaches 0 plus log of x power x. And we all know already that the power will become coefficient of log according to the properties of logarithm. So which is equal to limit x approaches 0 plus x into log x. And I will convert this into what form means I'll convert it into 0 by 0 form. How can we convert it? X is approaching 0 plus na, so this is taking value 0 and this is log of 0 plus. Log of 0 plus is infinity. So it is in 0 into infinity form. I'll convert it into 0 by 0 form or infinity by infinity form in order to use L'Hospital's rule. So in the next step, what I'll do is limit x approaches 0 plus. I won't take log x to the denominator, but I'll take x to the denominator. So in numerator, we will have log x. And into x, if it goes to the denominator, it becomes divided by 1 by x. Right? Now, it is in the form of infinity by infinity. So, we can easily apply L'Hospital's rule. So, what is it? Numerator derivative divided by denominator's derivative. So, log y base e. We are finding log y base e. Remember this. It is equal to limit x approaches 0 plus log x derivative. Log x in the sense log x with base e. Keep this in mind. Okay, now. So log x base e derivative is 1 by x divided by 1 by x derivative is minus 1 by x square. All these are basic derivative functions. We must remember them. 1 by x derivative is minus 1 by x square. And after cancellations, we are left out with the limit x approaches 0 plus minus x. Now you can happily substitute x value as 0. So I'll get minus 0, which is 0. What is 0 here? The answer is not 0. Log y base e is 0. Now again, converting logarithmic function to exponential function, we get y equal to e power 0 and the value is 1. So e power 0 is 1. Therefore, dear students, the answer for this particular question is 1. Okay. Using this particular function, let me find the limiting value of next function. So using the previous function, limiting value of the previous function, I will find the limit of this particular function. It's very easy. What they are asking is limit x approaches 0 plus x power x. Keep this in mind that x power is x power x. Don't misunderstand that x power x is x power x square. It's not like that. X power, what is the power here? X power x. So what I'm going to do is, let me use the previous limit. For that, I'll give the limit for the base and also for the power. I'll give the limit for the base. So limit x approaches 0 plus x power. I'll also give the limit to the power. Limit x approaches 0 plus x power x. So we discussed this in the rules of limits topic. Okay, it is there in playlist. You can go and check it. So when x is approaching 0 plus, you can substitute 0. Power. What is 0? What is the power, dear students? Just now we have found this value. This value is 1. This is this only, na? Its value is 1. So 0 power 1 will be 0. The answer for this particular question, second question, is 0. I hope you understood this. Can you try this question? Third question. And can you try this question? Limit x approaches infinity, x power 1 by x. If you directly substitute the base is infinity and power is 1 by infinity, which is 0. So it is taking infinity power 0 form. It is taking infinity power 0 form. Follow the same method which I used to solve the first question. Okay na? So let this is y, apply log on both sides and follow it. Okay na? You will get the answer certainly. Okay. So try this and let me know what is the answer in the comment section. So we will go with next question. Here is our fourth question. Limit x approaches 0 plus sin x power tan x. And before I give you the solution, have you thought why x is taking only 0 plus, why x is approaching 0 plus, why not x approaches 0 minus? In case if x approaches 0 minus, it is sin of 0 minus. That means sin of an angle just less than 0. That angle less than 0 is in fourth quadrant and sin x will be negative. The base will become negative. To avoid the base from being negative, to avoid that, we are not taking x approaches 0 minus. Okay na? So we are taking only x approaches 0 plus. Okay, see how to solve this question. Just like the first question, I'll take this function as y. Y is equal to limit x approaches 0 plus sin x power tan x. Now let me apply logarithm on both sides. So log y to the base e is equal to limit x approaches 0 plus log of this particular function, log of sin x power tan x. And as usual, this particular power, it becomes the coefficient of log. It is a property of logarithm. Okay, so limit x approaches 0 plus tan x into log of sin x. And in next step, before going to next step, if you substitute x as 0, this is 0, this is taking 0. Sin of 0 plus is 0 plus, and log of 0 plus is infinity. It is in the form of 0 into infinity. So let me convert it into the form of 0 by 0 or infinity by infinity. So instead of taking logarithm to the denominator, I can take tan x to the denominator. That would be better. So limit x approaches 0 plus log of sin x in the numerator, and when tan x goes to the denominator, it becomes cot x. Now it is in the form of infinity by infinity. Correct or not? We can use L'Hospital's rule to solve this question. So once again, what are we actually finding? We are finding log y to the base e's values. I have applied log with base e on both sides. Okay. So according to L'Hospital's rule, what is it, dear students? Limit x approaches 0 plus numerator's derivative divided by denominator's derivative. Log x derivative is 1 by x. Then log of sin x derivative will be 1 by sin x. And don't forget into sin x derivative. So instead of x we have sin x na. So for that reason we should do into sin x derivative. So log of f of x derivative will be 1 by f of x into f of x derivative. Okay. Divided by, do you remember cot x derivative? It is minus cosec square x. Okay. A simple simplification. Limit x approaches 0 plus sin x derivative will be cos x. Cos x by sin x. And let me take this minus to the numerator. And when cosec square x goes to the numerator, it becomes what? Sin square x. So obviously sin x and its square will get cancelled. Now in the remaining function, you can happily substitute x as 0. So what will you get? Minus cos 0 is 1 into sin 0 is 0. So dear students, log y to the base e is equal to 0, and converting logarithmic form to exponential form, y is equal to e power 0. So which is equal to 1. So the answer for this question is also 1. This is y, correct or not? And its value is 1. I hope you understood this. Let us go to next question. Here is our fifth question. Limit x approaches pi by 2 minus cos x power cos x. It is same as the previous model, right? So you can do this question. Try this question and let me know what is the answer that you have got in the comment section. Okay, we will go with sixth question. This is our sixth question. Limit x approaches 0 plus x power 1 divided by log of sin x. If I directly substitute x as 0, what will you get? The base is 0, and look at the power. Sin of 0 plus is 0 plus, and log of 0 plus is minus infinity. 1 divided by minus infinity is 0. So it is taking 0 power 0 form. Okay na? So you should understand which indeterminate form the function is taking. Based on that only we will solve the problems, right? So it is taking 0 power 0 form, and obviously let us follow the process which we used in the previous questions. Let this is equal to y. Why can't you try it before I complete the solution? And let me apply logarithm with base e on both sides. So log y base e is equal to limit x approaches 0 plus log of x power 1 divided by log sin x with base e. Here also base will be e only. And here students, as usual, the power here becomes the coefficient of log. So what will you get is limit x approaches 0 plus the power becomes coefficient. So 1 divided by log sin x with base e into log x base e. So numerator by denominator, and if I substitute x as 0 plus log of 0 plus e is minus infinity divided by log of sin of 0 plus. Sin of 0 plus is 0 plus and log of 0 plus is minus infinity. Minus and minus will get cancelled. It is in the form of infinity by infinity. Okay. For that reason, let me use L'Hospital's rule. So according to L'Hospital's rule, you are actually finding log y value. Keep this in mind. Limit x approaches 0 plus. So what is numerator's derivative? Log x base e derivative is easy. It is 1 by x whole divided by, and log of sin x, already we have done this. Okay, now log of sin x derivative, it is 1 by sin x into sin x derivative, because log of f of x derivative is 1 by f of x, 1 by f of x into f of x derivative. Okay, now so 2 more steps, you'll get your answer. Limit x approaches 0 plus 1 by x. Okay, you can take divided by 1 by sin x, will go to the numerator now. So you'll get sin x by x. Correct or not? 1 by x, and when division becomes multiplication, it becomes sin x by 1. Okay, I hope you understood this. And in denominator, we also have sin x derivative, which is cos x. And dear students, already you know the limiting value of this particular function in trigonometric limits you learned. It is 1, and you can substitute x as 0. Cos 0 is 1. So what you got? Log y value is 1. You got log y base e as 1. Therefore, y is equal to e power 1. Converting logarithmic form into exponential form, you got y is equal to e power 1, which is e. Therefore, the answer for this question is e. So let us do one more question in this particular model. Here is our next question. Limit x approaches pi by 4, 2 minus tan x whole power 1 by log of tan x. So obviously, first try it yourself. Try it and let us see if you are getting the answer or not. Meanwhile, I am solving it on the board. Let this is equal to y as usual. And next we will apply log on both sides. So log y to the base e is equal to limit x approaches pi by 4 log of this particular function 2 minus tan x whole power 1 divided by log of tan x with base e, and as usual the power of this will become the coefficient of logarithm according to the properties of logarithm. What is that property? The property is that log of a power m is m into log a. That is the property, okay, which we are using here. So limit x approaches pi by 4. The power becomes coefficient na 1 divided by log of tan x base e into log of 2 minus tan x. Now if you substitute x as pi by 4, tan pi by 4 is 1, 2 minus 1 is 1, and we are getting log 1. Log 1 is 0. So the numerator is taking the value 0, and here also if you substitute x as pi by 4, tan pi by 4 is 1, log 1 is 0. So the function is taking what form, dear students? 0 by 0 form. So we are going to use L'Hospital's rule in the RHS. So we are finding log y base e value, right? Log y base e is equal to, with this particular limit x approaches pi by 4. Numerator's derivative, as I told you already, log of f of x derivative is 1 by f of x into f of x derivative. So we will write 1 by 2 minus tan x into 2 minus tan x whole derivative, whole divided by, and in denominator we have log of tan x. So log of tan x derivative is 1 by tan x into tan x derivative. Next, dear students, limit x approaches pi by 4. We are very close to our answer. 1 divided by 2 minus tan x into 2 derivative. See, in addition or subtraction, the derivative will be separated. 2 derivative, the number derivative is 0 minus. Okay, tan x derivative. Tan x derivative is secant square x divided by 1 by tan x into, again tan x derivative is secant square x. So secant square x will get cancelled, but remember minus is there. So limit, again I can substitute the x value as pi by 4 in the remaining part of the function. So minus will be there. 1 divided by 2 minus tan pi by 4. I am substituting tan pi by 4 is 1 whole divided by 1 by tan pi by 4 is 1. So what is it, dear students? We got the answer as minus 1. What is minus 1? Log y base e is minus 1. Then y is equal to what? E power minus 1. E power minus 1 is 1 by e. Therefore, answer for this question is 1 by e. So I hope you understood all this problems. The problems on 0 power 0 form and infinity power 0 form. You can find more models in your books and you can try solving them. I hope you'll get the answers for all the questions. Okay. See, dear students. So I think I have covered all the subtopics in the chapter of limits. Okay, na? So you can find all the subtopics in the playlist of limits. Our next chapter is continuity. But in case if I have missed any subtopic in limits, you let me know in the comment sections. I will find that particular subtopic and I'll complete it. Okay, na? And I'm also planning to upload more number of model questions on each topic. I'll do it certainly, but not immediately. At some other point of time, I'll upload different models on each subtopic. In case if you need more models on any given subtopic, you let me know in the comment sections. Very soon I'll upload different models on each subtopic and at the same time advanced model questions on each subtopic. Okay, so for now I'm just completing the playlist of limits and we are getting into new chapter, continuity. So we will be starting continuity maybe tomorrow. Tomorrow itself I think I'll start continuity chapter. Okay, now so I hope you are really enjoying these videos on limits and you are really understanding them and you are practicing them. I hope all these videos are useful to you. So do subscribe the channel if you are new and like the videos, share it with your friends, let the channel grow, spread some love. Okay, na? This is M. Sandeep Kumar. See you all in next video.